Hi, this is Kevin Trainer. Welcome to part 1 of my tutorial for chapter 6 of the third edition of the Zelle Python book. And in this tutorial example, we're going to do a classic conversion program. Okay, and I've already created this, so I'm not going to waste your time by typing and having you watch me type. So it's called inches to centimeters, so it does that conversion. And one of the major parts of the code here is a function, not the main function, but a level 2 function, as we often call it. We'll call the main level 1 and the things that it calls level 2. So a level 2 function called inches to centimeters. And I've got to tell you that I did not intentionally call the method the same thing that I called the overall program. But I guess this is a nice opportunity to show that this can be done. The name of the overall program or module is controlled by the name of the file that it's in, inches to centimeters. And of course, the name of the functions are defined in the function definition. And the functions within a module, a .py file, have to have unique names. We can't reuse the names within that .py file. But it turns out that it's okay if the name of a function in a .py file is the same of the main part of the name of the file. Typically I don't do this, but it turns out that it works, so we see it. So here's a function, okay? It's called inches to centimeters. I guess it could have been called convert inches to centimeters too. And we have one formal parameter called my inches, okay? And why did I say my in front of inches? Well, I always like to emphasize the fact that these formal parameters are not the same variables as the parameters that are in the calling code. So at times you'll see me put, the inches, my inches, and inches. I just want to really emphasize, even though the name of the formal parameter can be the same as the actual parameter, I'd like to emphasize to you that that's only coincidental. Okay? And what did I do here? Well, I returned my inches, the parameter in, times 2.54. Okay, it turns out that 2.54 is the conversion factor for inches to centimeters. Okay, so now I want to point out a couple of things. Well, I'll show you alternatives a little bit later, actually. Okay, so let's look at the main. So we prompted, please enter the measurement in inches. So we got that back. This is interesting. It shouldn't say eval. It should say float. Very nice. We fixed that. That was wrong, right? We're not using eval anymore, are we, team? Okay, so we did float. Then we do centimeters equals inches to centimeters, and we pass the actual parameter of inches. And then we print the result. And I'd like you guys to get some practice at using this string.format way of printing such that we learn to control the rounding. Okay, so we're saying here this is the 0th argument that we're going to get, centimeters. 0 says it can be as wide as we want it to be. 0.2 says 2 decimal places, and F says fixed format. Okay, so we want that. So let's just run this. Okay, so I'm going to give it a run and come down here and make this a little bit bigger. So inches to, please enter the measurement in inches. I'm just going to say 2.0. And I'm going to get the answer 5.08. Okay. That's fine. What if we had, so 5.08 looks like it didn't have to do any rounding. So let's try another one. Let's run it again. Okay. And instead of saying 2.0, let's give it something that'll give us some extra fractional values, like 2.5 inches. And it says that's 6.35 centimeters. Okay, that's good. All right, so now notice we didn't do the printing in the function that did the calculation. And this was really intentional, okay? In the past, in the previous couple of chapters, we've been doing a lot of printing, and one of the reasons that we do so much printing is it's the first thing we teach you how to do, okay? And so there are examples in the textbook where we have a level 2 function that we call, and it does the printing itself. Well, it turns out in terms of designing programs properly, we ought to design a program such that it's easily changeable, right? So for instance, right now, we've decided that we're printing the answer out to the console. What if we decided we wanted to print the answer out to a more formally named output file, a text file? Well, then we would have to we'd have to go and change this code. Okay, and every time we change a piece of code, we have the possibility we're going to introduce an error. Okay, and of course we could wind up with 2 versions of this code to maintain. We would have the one that prints to the console, and then the one that prints to a file. Right, and it just could go on and on. What about one that does the conversion and prints it to a web page? It just keeps. There are all kinds of potential outputs that we want. So doing the calculations and formatting and printing the output are 2 different operations that are best kept separate from each other. And so what we do here is we only do one thing in the function. And we're going to emphasize this a lot. When we get to chapter 9, we're going to be talking about, we want functions to have some good properties. And one of them is called cohesion. And cohesion is the property of having all of your code being about the same thing, right? And the version that we have here is very cohesive, right? That's one of the things that makes it so good. If we included the printing, wouldn't it really be about 2 things? It would be about doing the calculation and doing the printing, okay? And the problem is maybe one should change when we don't want the other one to change, okay? So that's the cohesiveness argument is another reason why this current version of the code is a good version. All right, now, some people ask me if the code that I have here right now is the only way to do this. Okay, this is very summarized. It has a one-line body for the function, and I'm going to say no. Okay, let me put this into a comment. Okay, and let me show you the long version. Okay, we could say this. We could say something like this. We could say result equals my inches times the conversion factor, 2.54, and then we could say return result. Okay? Now, are we going to get the same answer? Well, let's look. If we give an input at 2.5, we should get 6.35 back. Okay, we'll do it. Run it again. Make the type a little bigger so we can see it. 2.5 is input, 6.35 as the result. Is one of these better than the other? I'm going to tell you no. A lot of people would tell you, well, you know, there are 2 lines of code in this longer version. It's less efficient. It's, to tell you the truth, it's so the difference in the efficiency of these 2 versions is very, very slight. Every once in a while, what I do is I do an experiment where we take a code like this, and we have 2 versions, and we run them a lot of times. Like first we run the 2 of them 100 times, and then 1,000, then 10,000, then 100,000, then 1,000,000. Well, first of all, it's very impressive how quickly you can call this function 1,000,000 times. I mean, is there a delay? Yeah, there is. There's a delay of a second or 2 or 3, but 1,000,000 times is a lot of times, okay? And when you compare these 2 versions over even 1,000,000 invocations, they're not very different, okay? So if you're a new programmer and this new version here is a better version for you because it's clear that we calculate the result, then we return it, by all means, feel free to do it, okay? The only thing I'll say, if we back up, I'm going to do these undos. Undo, 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 and one more undo. Okay. This is the common Python style, okay? And in the Python world, the Python people are pretty full of themselves. Rightly so. They've accomplished a lot. And when something is done like a real Python person, they say it's Pythonic. Okay, so the version I've showed you here, the first version, the short one, is Pythonic. This is a way Python coding jocks would do it. The difference between that and the more beginner version is not really that different. Okay, to beginners, maybe the beginner version reads a little better than this shorter, more Pythonic version. Okay, but to experienced Python people, they mean the same thing. And why not do it shorter? Okay, so I'm going to give you the latitude to do one or the other, but I just want you to know the Pythonic way. Okay? All right. So what we've done here is that we've really separated the functionality of getting the input and the output, getting the input and formatting and printing the output for this problem from the actual calculation in the conversion. And this is a pretty good way to separate functionality. Now, the main the code that's in the main here is not that reusable. I mean, this is a pattern that we follow a lot, but could we really reuse that code? Well, no, it's so specific. It's probably only good for this one application. But what's interesting is that we do have some code here that we could use in other contexts, okay? And one of the things we're going to learn how to do eventually is to create our own module of reusable code pieces, okay? We're not doing that yet, but this is certainly something that we could do. All right, so that's it for part one in the version that you're going to do for your exercise, your assignment. You're just going to do a different conversion. And if I recall, I think you're rounding to a different number of decimal places, so pay attention. But other than that, it should be pretty straightforward. So you go work on that, and I'll say bye until I come back for part two. See you there.